Hello, everyone, and today we are going to be continuing with our arrow lessons on how we can do hypothesis testing in arrow. Hypothesis test is used a lot, especially those of us that are doing research. Most of the times, you might want to compare maybe the height of students in a class between male and female, and actually, you might be thinking of that height to maybe a particular value, but you need to collect data, to be able to make that decision. Um, so most of the times in this case, we are going to be using hypothesis testing. For hypothesis testing, we are going to have two cases. Cases when we know actually the population standard deviation sigma. Most of the times, we might not know this value, and which is why we are going to be moving mostly to what we call the T distribution, which is what we are going to be using if, especially if you are collecting a sample. But for cases that we know the standard deviation of that population, we are going to be considering that distribution to be a normal distribution. So let's take, for example, that I wanted to maybe, I know the standard deviation, and I was trying to check if maybe the mean of in maybe height in a particular class that is greater than what 15, maybe 15 um, centimeters is just something, it's just a scenario that we are looking at. So now, for hypothesis testing, we have two ways and one way hypothesis testing. So this is just like we are looking at the alternative here, which is what our hypothesis of interest, that this mean is greater than what 15. The null hypothesis, we use it a lot to be able to make judgment whether what we are trying to test is correct or not. So let's say, given that we know the mean of the height in that class, which is, let's say, is that we estimated, and we have 17.2, and then we know mu zero, which is what we have here, and then we know sigma. Sigma here is just that population standard deviation. When we have some questions that we go through, you are going to understand why we are using this. I can just look up something, maybe let's say I have some questions. Let me just pull them up. Okay, I let me just bring out this. So let's say I have something like this. We can see this question 7, where we are saying to use a normal distribution and the sample result to complete the test of the hypothesis. We are using a significant levels of 0.5% most of the times to be able that when we calculate the p-value and it's less than this value, 5%, we are able to reject the null hypothesis in favor of what the alternative. Please try to go through the notes that I sent in the WhatsApp group, so actually you understand what we're talking about here. Let's say I want to test here that mu is greater than 15, which is what we are having in our R. We have the estimated mean, which is x bar, as 17.5. We already know the sigma, and the sample of the we collected n was what 40. So this is some of the cases, and this is what we are trying to use here in the case of R. So first things first, we are going to calculate the Z statistics since we are using the normal distribution, which is that mean we calculated minus the mu zero divided by sigma, the square root of what n. So if I run all of these, run these, our n, I can run that z, right, just to get that z value, which is this. Now, since we are dealing with the normal distribution, we already saw this p norm previously in the previous video, which we're trying to calculate p values for the normal distribution and so on. Now, since, because most of the times, if you look at the normal distribution, we are always interested towards the area on the left. So since the hypothesis here is towards the right, where we are looking at mu greater than 15, we are going to be having what the p-value here to be 1 minus p norm of what the z value that we calculated from here, since we are interested in towards the area towards the left, which is 1 minus you know what we have towards the right. So if I run this p-value, we see that this p-value is around, should be around 10%. So, but we are interested to make a decision, we have to make sure that the p-value we calculated here is less than that alpha, which is the 5% that we had. I can set alpha here, alpha of I'm setting that alpha to be 0.05. So so if I run this and then I'm trying to check, so to be able to reject the null hypothesis in favor of the alternative, we have to check whether the p-value we calculated is less than that 5%, so which is true. Yeah, that, no, let me see, the p-value we calculated was like 1, yeah, it's like 1%, which is always less than the alpha value, which is what, 5%. So in this case, what are we saying? We are going to reject the null hypothesis that mean is equals to 15 in favor of the alternative, to say that what, mu is always greater than what, 15. So another use example that we have here is the B part of this question, which we are having mu as 100. The estimated mu value here is 91.7. So same thing, since we are using normal distribution, we'll go through the same thing. We'll run this and then calculate that z-score. You can see how to calculate that z-score there. We already have that formula in the notes I sent to our WhatsApp groups. And then we run this and then we can calculate that p-value. We calculate that p-value, we see that this p-value is very small, so it will always be less than that alpha. So we are going to reject the null hypothesis in favor of what? The alternative. That is the case. No, there are cases where that is when we are using the, now we notice here that I did not use 1 minus here in calculating that p-value here, because already that area was towards the left side, because mu here, we are testing whether mu is less than what, 100. So that's why my p-value, I only use p norm of what, this z value that I calculated. There are cases where we can use maybe two-way when we are checking if the mean is equal to or whether mu is not equal to what, 500. That is like a two-way test. So in that case, the way we calculate that p-value, since it is a two-way, we are calculating that middle area. If you go through the note, you should be able to see that we are going to just calculate that p-value considering that right side and then multiply it by what, by 2, if it is what, a two-way test, which is something like this. A two-way test is something we are testing that the mean is not equal to a particular value. We are going to go, if you are testing for maybe that the mean, two mu values are not equal to each other. Maybe you are looking at the height of students, female students in a class that are not equal to the height of the male students. We are going to see how we can go about that too, as we go on to more into this hypothesis testing. So now we have seen cases that we know the standard deviation. What if the population standard deviation is not known? So in this case, we are going to be using what we call the sample standard deviation. Samples, in this case, we are going to be using what we call the student t distribution, which in most cases in hypothesis testing, that is what you are going to be using in most of the cases. Because when you are trying to carry out an experiment, you might not really know the true standard deviation. So most of the times you estimate it from the data that you collected. So in most cases, whether in real life scenario, we will use mostly what, these cases where we do not know that population standard deviation. And most of the times when you are doing hypothesis testing, if you look at the note, there are conditions that we need to, to be fulfilled. We check whether the data is coming from the normal distribution and so on. And most of the real world scenarios, we don't have that data coming from the normal distribution. Then how do we estimate this? Go through estimating the p-values and so on, which we are going to see all of that, which will be bootstrapping as we go on. So let's say we do not know that population standard deviation, and then we are going to estimate it based on the data that we are collecting. Let's say we are trying to test that mu is equals to 10 versus the alternative that mu is greater than what? Than 10. So here, it is a little bit different. The way we estimate that t statistics is we are going to be using what? S, which is now, since we do not know that population standard deviation, we are going to be using the one we estimated. So I run this here, run. We have n to be what? To be 12, and then we calculate that t statistics. And then from there, now, because we are using the t statistics, the degrees of freedom Uh, just go through those notes, you understand what we mean by the degree of freedom, which is used a lot to be able to calculate that p-value. Now we are using the right tailed p-value. Now, because we are using the student t-distribution, we are not going to be using p norm as before for the normal distribution. We will use what? pt, that the probability of that student t-test. So it will be 1 minus pt. T here will be what? The t statistics we calculated from here, and then the degrees of freedom we what? 1 minus what? Minus n minus 1. So if we run this, and then we can check it with that alpha value, we see that the p-value we calculated here is far more greater than that alpha value. It's more than 5%. So in that case, we do not have enough evidence to suggest that what? That this mean is greater than what? Than 10. So what if it is a a left tail distribution, which in that case we still have the same thing, but the only difference we have here is the way we calculate that p-value. We are not going to be using 1 minus. We will only use pt. We get that t test we calculated, the degrees of freedom, and so on. So take note, because most of the time, as I did mention, we are going to be using these t distributions a lot for real world problems. We run that, we know our degrees of freedom, and then we can calculate that p-value since it's the right test, and then we run this. We see that here this p-value is very small, and then we can vividly say that there is that evidence that the mean of that sample is less than what? 120. So what more if it is what? Something that we are comparing means of maybe that the mean is not equals to 4, which is like a two-way test. So we are going to use similar method we use above, but the only difference is here is that we are using the absolute value here to make sure that if that t statistics is what? Is negative, we are going to be having what? A positive. Because we cannot calculate the probability of a negative value. You have to be careful. That's why we are using this absolute value here. So same thing. We are going to run these, run that mu, standard deviation, we run that t-test, degrees of freedom, and then p-value. Then p-value, we see that this p-value is pretty very what? This p-value here is very, very, very high. So we see that the decision that we are going to be making here is false, right? Because p-value is not less than alpha. So in that case, we do not have enough evidence to suggest that the mean of that sample is different from what? Is different from 4. So we have seen here that in most of these cases, we are only trying to look at to test a single mean. Now, as we move on, we are going to see how we can test if we have two groups. Let's say we were trying to test that the height of female students in a particular institution, that the average height is different from that of what? Of the male students. That we are still going to collect a sample, and then in that case, we collect sample for female, we collect samples for male, and then in that case, we are going to see how we can check that using what? Two population means, not this single mean that we have been using throughout this video. That will be what we are going to be looking on for the next video. Thank you so much, guys, and keep following for more of these tips.